Where do complex numbers live? It turns out that complex numbers live on what is called the complex plane. It is a plane that is comprised of both the real number line as well as the imaginary number line. Now, back in pre-algebra and algebra 1, when you did math, you would do math on the real number line. Here's 1/2, here's 3.14 approximately pi, here is negative 2/3 over here, so on and so forth. So when you solved, when you graphed, it was all on the real number line. It turns out that there is another number line called the imaginary number line. Here's I, here's 2I, here's 1/2 I, and remembering, of course, that I is equal to the square root of -1. Here's negative pi I way down here below negative 3I, and so on and so forth. So if we wanted to talk about a specific number, a complex number, for example, the number 2 minus 3I, well, this has two components to it. It has both a real component, which can be found on the real number line, as well as an imaginary component, negative 3I, which can be found on the imaginary number line. So when we graph, or when we plot 2 minus 3I, we go to 2 on the real number line, down to negative 3I on the imaginary number line, and here is the graph of 2 minus 3I. That's where that lives. Let's try another one. How about -1 plus 2I? Well, -1 plus 2I, our real component is -1. Our imaginary component is 2I. We go to -1 on the real number line and up to 2I on the complex number line, on the imaginary number line. And here we are at -1 plus 2I right there. And that is how you graph a complex number. Now the next question is, how can you find the absolute value of a complex number? Well, for example, on the real number line, let's recall that the absolute value is the distance that a number is away from 0. For example, the absolute value of 2 is equal to 2 because it's 2 away from 0. Likewise, the absolute value of -2 is also equal to 2 because that is also 2 away from 0. However, when you're talking about complex numbers, it's not that easy to determine how far something is away from 0, but it's also not that hard. So let me show you an example. Let's say that our complex number z is equal to 4 plus 3I. Then we say that the modulus of z, which looks like the absolute value of z because it's the distance away from 0, is equal to the distance that z is away from 0. Well, let's first plot 4 plus 3I. 4 plus 3, here's 4, here's 3I. Here is where 4 plus 3I lives. And now if you draw a line from 0, 0 to 4 plus 3I, that is going to be the distance that it is away from 0. Now, remembering back to geometry, the Pythagorean theorem, we know that this is a hypotenuse of a triangle whose height is 3 and whose length, or whose base, is 4. So we have height 3, we have base 4, and the question is, what is the hypotenuse? Well, to find that, we can just do z squared, or mod z squared, modulus z squared is equal to 4 squared plus 3 squared, because c squared equals a squared plus b squared. This means that the modulus of z squared is equal to 25, which means that modulus z is equal to 5. The Pythagorean theorem allows us to find the modulus of a complex number. So modulus z is equal to 5. Furthermore, we can find a general formula for the modulus of a complex number. Let's say that z is equal to a plus bi. Z equals a plus bi. Well, we're going to go some distance a along the real number line, and we'll go some distance b along the imaginary number line. So we'll end up somewhere around here. That hypotenuse will be given by length a, or base a, and height b. So let's consider this for just a moment. If z is equal to a plus bi, then the modulus of z is going to equal, well, the modulus of z squared is going to equal a squared plus b squared by the Pythagorean theorem. Base squared, which is a, plus the height squared, which is b, and of course the modulus of z is our hypotenuse. That means that the modulus of z is equal to the square root of a squared plus b squared. And this is how you find the distance that a complex number is away from 0. The modulus of a complex number is a lot like the absolute value in that it is the distance away from 0. Thank you for watching.